Okay, so there are three basic units of measurement. There's the metric system, the English system, and an international system called the SI system, which a lot of scientists tend to use just to sort of keep things consistent. Here we're going to focus on the metric system, where there are three base units known as the gram, which is abbreviated with a lowercase g, a liter, which is abbreviated with a capital L, and meter, which is abbreviated with a lowercase m. Gram measures mass. Liter measures volume. Meter measures length. You have to know the base units and their abbreviations. Capital letter matters for liters. Lowercase is not acceptable in my class. Table 2.2 in your chapter handout lists the prefixes that go in front of the base units. You have to memorize the prefix, the corresponding symbol, and the power of 10. You may cross out the column that says multiplier because you don't have to know that. Okay, now we're looking at student exercise number 1, where it says give the symbol for each of the following metric units and state the quantity measured by each. Okay, so we're looking at A, and I want nanoseconds. Nano is an N, and seconds, as I pointed out in the chapter handout, is a lowercase s. So nanoseconds is measuring time. B, milliliter. Milli is a lowercase m, liter is a capital L. That measures volume. C, decigram. Deci is a lowercase d, gram is a lowercase g. You're using this to measure mass. D, megameter. Mega is a capital M. Meter is a lowercase m, and it measures length. Now, when we're using these prefixes in the base units, we're using them to relate quantities, okay? And I need you to write them out in a certain way. So if we're looking at student exercise number 2, where it says 1 megameter equals how many meters, then what you're going to do is notice that the number 1 is written next to the prefix. When you have 2 letters in a unit, the first letter is the prefix, the second letter is the base unit. You have to recognize that, okay? And the number 1 is always written next to the unit that has the prefix in it. It equals the corresponding power of 10. If you look at the table, mega is 10 to the 6th power. So we put 10 to the 6th here next to the base unit. So when you have a 1-letter unit, it's the base unit, okay? All right, so this is how it gets written in my class. This right here is a unit equation. A lot of students get confused and they think that they don't know what the unit equation is and that I never mentioned it, but actually it's typed up for you in your chapter handout and I've discussed it here. So when I ask you to write a unit equation, this is exactly what you have to write. The number 1 next to the 2-letter unit, which has the prefix first. And that gets set equal to the power of 10 next to the base unit. For B, we have 1 kilogram equals how many grams? Notice the number 1 is next to the 2-letter unit. The first letter is the prefix, the second one is the base. It equals the power of 10 that corresponds to kilo. Kilo is 10 to the 3rd. So here we have the power of 10 next to the base unit. Okay? Now, unit equations, which always contain an equal sign, may be written as a fraction. This is something that a lot of students don't understand either. So you're going to want to write this down. If I decide to write my unit equation as a fraction, like 1 megameter over 10 to the 6 meters, it would look like this. This is one of the fractions that you could have. Or you could have flipped it and put the power of 10 on the top first, and then the other one on the bottom. Okay? So these are the two corresponding unit factors, which is what your book calls them when they're in fraction form. They have a division symbol. Okay? You have to know the difference between writing out a unit equation and a unit factor. Alrighty? Okay,